Hello everyone. I wanted to make this video to give you guys an introduction to SolidWorks Motion. So let's get started. The examples I'll be using to show you guys about SolidWorks Motion is the assignment 11. So we'll start with the V block assembly. So to do any sort of motion, you have to have an assembly done and mated properly. So assuming you're at that point, you've already finished your assembly, it's completed. If you look at the tab where it says motion study, that's where you click on. And initially, you might only have animation and basic motion. The motion analysis might not be there. So if that's the case, what you need to do is go to, is it tools? Go down to add-ins. So I have SolidWorks Motion already on, but if you don't, if you have it unchecked, make sure you check it off. And I think, I'm not sure, but you might have to reboot SolidWorks for it to pop up um, down here. So if it pops up on its own, great. If not, check off that box and reboot SolidWorks to get that to show up. But the whole point of this motion tool is so we can make things move, make assemblies move in a similar way that they would to in real life. And then we can study that motion. There's a bunch of different things we can do, but we'll keep it simple for now. I would say one of the main things to do on a motion study is to add movement through motors. Let's say in this case we wanted our V what is this called? The V clamp, the V block clamp to move linearly along the block base. We could go down here, we can add a motor, can add a linear motor to be specific. And then you click on where you want to add it. The red arrow shows you in which direction it's going to move. If you want to flip that, click on the reverse direction button. But let's say in this case you want to move it towards us at a constant speed of 1 inch per second. So go ahead and hit OK. And then now we can see that a motor was added in and it's going to run for 5 seconds. So if you hit the calculate button, that calculates any changes that you've made. So let's calculate that. And then it shows us that the clamp is moving towards us. But again, it is restrained by its mates that we added earlier. So it's confined by the mates that are added in the model. So what this red tells us here is that this motor is pushing, but there's no longer any movement there. So if we wanted to, we can add a stop key to the motor. So the first one is our start key. If we hover over more or less where the motor is going to stop, you can right click there. You can place a key. But you also have to change that to an off key. And as you can see now, there's no colored bar there because this marks my stop for that motor. Um, if you want to move it, you can drag it, click and drag and move it to a different location. But if you wanted to be more specific about where to start and stop, if you right click on it, you can edit the key point time and then type in a specific value uh, that you want to stop it at, maybe like 1.4 seconds. And again, if you make any changes, hit calculate to calculate those changes. So as you can see now it stops, that motor stops at the 1.4 second mark. You can do the same thing for the top key, which marks how long the animation is going to run for. So I can also change this to 1.4 seconds, and that way it stops at that point. Um, you can also add additional motors. So let's say we wanted to now push it in the opposite direction. We can again add a linear motor. Flip the direction this time. I'll choose the same constant speed. Um, but we don't want to place it here because now these two motors are going to be fighting each other, moving in opposite directions at the same time. So what I would do is, let's say this one is currently stopping at 1.4. I want my start for my new motor to be, I don't know, let's say 2.4 seconds, right? Let's give it a second of stopping time. And then let's add another key for our stop. So let's change that to, say, 1.4, 2.4, 3.8 seconds. So now the first motor runs for a total of 1.4 seconds. Going to stop for 1 second, and then it's going to run for another 1.4 seconds in the opposite direction. So let's see what that looks like. Cool. It's about what I wanted. Let's see what else. You could also change the frames per second of the animation, depending on how good of a machine you have. The default is 8 frames per second, but if you wanted to run it at something a little bit faster, you could do that. So hopefully that makes the motion look a little bit smoother now that it's capturing more frames per second. Um, and the same settings are available for the basic motion and the animation. So now we have our slider, moves front, stops at its limit, moves back towards the center somewhat. Now let's add a rotary motor to the screw. So let's add a rotary motor to the screw. That's not what I wanted. All right, so the initial direction is counterclockwise. No, sorry, clockwise. So it's always righty-tighty, lefty-loosey. As it turns clockwise, it will tighten into the clamp. And if it's turned counterclockwise, it's going to loosen or back its way out. So we'll keep it at 100 RPM. So that would be 100 rotations per minute or 100 revolutions per minute. So let's add that motor. Again, it's added at the very beginning, which would be fine if you want it to run simultaneously. However, the motion that I'm going for is let's move the clamp this way, let's move the clamp the other way, and then after it's done moving, then we'll start screwing in the screw. So our clamp stops moving at 3.8 seconds. Let's say we start this at 4.8 seconds. Again, let's give it a second of uh, pausing time in between. You don't have to, but that's how I want to run mine. Let's add, if we right click, let's add another key. So this key, I want to maybe allow the screwing motion for 3.8, I don't know, let's say 6.8 seconds. So 3 seconds total. Um, See, I'm not sure what happened here, but uh, this is supposed to be my off key. I think I might have changed it to an on key. So this should be on right now, which if I right click on it, it'll let me toggle it off. That's good. But if I right click on this, it also lets me toggle it off, meaning this is currently an on key. So I want this motion to stop so I could change that to an off key by right clicking and clicking on off. Okay, so this is an on key and this is currently an on key as well. Let's make sure we turn that to an off key. So then let's run our simulation, see what that looks like. Cool. So it looks like after, a certain amount of seconds, the clamp reaches the bottom as is shown by this red here. So again, we can edit this, or you can also place a new key at this point and delete the old one. So at 5.9 seconds, it reaches the bottom. So let's see what that looks like now. Let's calculate that from the beginning. Movement, movement, screw in, then it contacts the bottom. And then, if you wanted to, we could also add a fourth motor. This time the screw again, loosening it counterclockwise at the same constant speed of 100 RPMs. Um, Let's see, this one runs from 4.8 to 5.9, so that's 1.1 seconds. Maybe this one we can make it run something similar. Um, so let's see, this stops at 5.9. Let's start this one right at 5.9. And let's place another key for, let's see, 1.9. Let's run this for 1.9 seconds. So 5.9 plus 1.9 is 7.8. Did I do my math right? This runs from 4.8 to 5.9. So that's 1.1 seconds. So no, I didn't do my math right. And then this one's going to run from 5.9 to 7 seconds flat. So they're going to run for the same time. Um, okay, let's calculate that again from the beginning. Movement, movement, tightening, and then loosening. Um, let's see, is there anything else? I would say that's about it for this example. So once you're done with your motion study, you save it, you save your assembly, rebuild it if you have to. And so if you close this, um, let's say you submit your assembly file, this motion study is now attached to it. So that can always be viewed or changed again after. So just a brief explanation of the differences between animation, basic motion, and motion analysis. Animation is the most simple of all. It does not include any physics with it. It's just the simple movement of your assembly file. Basic motion is like a little bit above that, where it does include some physics, like mass, gravity, and collisions, for like some more realistic simulations. However, it's still below motion analysis, which is like the full the full deal, right? It has um more detailed physics involved. You can use it to calculate things like dampening and impact effects, to determine other forces. So we'll for the scope of this class, we'll mainly deal with a basic animation or basic motion. However, for some, I think assignments, you do need to know how to do some stuff on the motion analysis side, but we won't go too heavy into it, um, which actually is going to be in the next example. So let me close this and then open up again, assignment 11, problem 3 was our inverted crank slider problem. So again, we're assuming you have your full assembly already done and it's constrained properly with the mates and everything is working as it should. So same as before, we go over to the motion study. I already had one made, so ignore this. You can make, if you right click on the motion study, you can create a new motion study. Let's start from scratch. So we'll be doing a motion analysis on this one. Because I want to show you guys how to trace a path, since I think that's going to be included on your assignment 13. So I want to make sure you guys know how to do that. But it's essentially the same thing. Um, let's say we want to add a rotary motor to the crank this time. So we can click on the edge of the crank. Let's go clockwise at first. Let's 100 RPMs might be a little too much. Let's change this to like 25 RPMs. All right, so that's added in. Let's calculate it to see what the let's see, there's an error here. Rhythm has locked up, at least one constraint can only be satisfied. Okay, so there's a constraint which can no longer be satisfied. Hmm. I'm not sure which one that is because there's no errors popping up. But it does not like this. Maybe let's start with something. Delete this motor. Let's start off with would it like to do an animation? Let's see, let's do an animation. Again, edge of the crank. Let's go clockwise. Let's do 25 RPMs. Let's run that. Okay, so it is running an animation. Um, However, I don't like how choppy the visuals are, so let's up this FPS to something better. And there's a little bit of a smoother motion there, which is what I wanted. That's cool. Um, this is running for too long, so let's add a stop key. Let's say we run this for 2 seconds total. So let's add a stop key at 2 seconds, and let's make it a stop key. Let's add another motor. So let's say we run it clockwise for 2 seconds. Let's add another motor counterclockwise at the same RPM, 100 RPM. But this time let's do it from 2 seconds. Start time. Then we'll run it for another 2 seconds. So stop it at 4. Let's see, place a key. Make that an off key. And then we can stop our simulation at 4 seconds as well for now. So it's gonna run clockwise. Let's see. Is this an off key? Yes. That's an on key. This is also an off key. Let's space this out a little bit in between. So let's do from 0 to 2 seconds. We'll run it, and then we'll take a second pause, and then we'll run it from 2 to 5. See what happens there. It's like bugging out. Hmm. I wonder if having two motion studies is kind of causing it problems. Let me go back to my original. So I had something similar set up earlier where I have the crank rotating uh clockwise, and then it's pausing for a second, and then it's rotating counterclockwise. So this is the exact same setup we were just looking at. First motor is rotating clockwise, like I said, at 25 RPMs. And then what I learned is actually something I learned right now. For the motion analysis, um, let's say you don't have, let me suppress this motor. So I added this motor because the motion analysis turns out, let me actually suppress both of these. Let me just run it like that. So even though I have a stop at the 5 second mark, it actually keeps spinning. That's not true in the animation. In the animation, if you have a stop and you have nothing after, like it will stop. But for the motion analysis, if you want something to stop, like a motor, for example, you have to actually add in another motor which rotates it at 0 RPMs, so it doesn't rotate it at all, right? So you have to add that in. So let's see if I unsuppress this now. So it should rotate up till 5 seconds, and then from 5 to 6, it should do nothing. So unless you have that stopping motor, it won't stop on its own, even though you have a stop key there. That's something I learned today. So in this example, again, we're rotating clockwise at 25 RPMs for 5 seconds. We're going to stop for a full second, and then we're going to rotate counterclockwise for another, what is 6 to 11, so another 5 seconds. Um, but the reason I wanted to do a motion analysis on this one is because I wanted to show you guys how to plot the path of something. So let me get rid of this so I can show you guys how to do it. So under motion analysis, you'll have these tools, which you don't have in the others. You have results and plots. So if you click on that, you have a bunch of different options for results. The one we want is for displacement. So pick the first one. Want to trace a path. And for this crank, you would want to click on the edge of it because it's going to mark the center of that crank. Um, yeah, and that's all. That's all you have to do. And then now under our results, we should have our plot. So when we run this, it's gonna trace that movement of the crank and it'll paint it on the screen. So that's something you guys have to do for assignment 13, which is why I wanted to add this in. Let's see, a few different things. You can also change the playback speed of the simulation. Um, what else can we do for now? I don't want to overload you guys with too much. Uh, Let me save this before I forget. Okay, so to finish up, I wanted to show you guys maybe a third example. But I didn't have one ready, so what I did actually is I went to there's a website called GrabCAD. In GrabCAD, you can search up pretty much anything. People post their files online, whether it's a part or an assembly. Um, just a bunch of random stuff. It's cool to look at. It's cool to download and just like kind of see what people are working on. But I was looking up like a gear set that I can use as an example, and I found this one. So what you do have to have an account, but if you have an account, you can download anything that people post. So I just downloaded this gentleman's files and then unzipped the folder, and then there they were. So now I can go into SolidWorks. Let me close this one. Go into SolidWorks, open up the files that I downloaded, and open up his assembly. And it's interesting because uh, I guess his files are in Spanish, so like it changed all of SolidWorks into like Spanish, or at least the naming that he had is in Spanish. So I thought that was kind of interesting. But I was looking at his gear set, and I noticed that although these two spin and are meshed together, and these two as well. Um, I believe, is missing one mate, which is to lock these two together since they're on the same shaft. So let's add the mate between this gear and this gear, and let's just lock them together. That way they rotate at all times together. So now if I spin one gear, should be spinning all the gears, which is that's nice. That's what we want. Um, so now let's go over to his motion study. Uh, Actually, do I need to create? Nope, we're good. This one's gonna work just fine. So we're at motion study now, and then let's see what happens if we add. Did he already have motors in it? Oh, so he already had some motors there. Let's see, he had one motor spinning this shaft at 10 RPMs counterclockwise. That's great. Let's do that for like 2 seconds. So let's add another key Let's make this the off key. Um, and then his second motor is different shaft, but also counterclockwise. Um, let's start this one at 2. Let's take a second. So we'll start this at 3. And then we'll end it at 5. So let's place a key here. Make sure it's an off key, and then is it at 5? Yeah, it's at 5 seconds. So let's see what happens now. Um, let's do more frames because that's pretty choppy. We'll do more frames. Let's run this for longer maybe. So let's do just 3 seconds instead of 2. We'll move this a second forward to 4. And then let's give it another 3 seconds of runtime. So we'll stop it at 7. And then calculate that again. We'll stop and then reverse direction. Um, okay, so I don't know, I'm just kind of playing with this now. 10 RPMs on the first one, and then this one was 10 RPMs on this one. So what happens if we spin, and these two, I mean, just by looking at them appear to be the same size gears, but see what happens when we spin one of the bigger gears at 10 RPMs. So let's say we spin this at 10 RPMs. So let's do another motor. For this one, counterclockwise, 10 RPMs. Okay, we'll start this at, let's do 8 seconds and then run time of 3. So this is gonna be my start. I need to place another key. This is gonna be my stop. So from 8 to 11 seconds. Okay, so 3 seconds each with a second in between. And I would also try to map the path for this one, but they're, you know, the centers, there's no components moving anywhere. Like they all rotate about their shafts. But I just wanted to show you guys a gear example because assignment 13 does have an example with gears. And actually I can pull it up here. So assignment 13 does have a planetary gear set for you guys to do a motion study on. Um, like I said before, the first problem does have you trace the path for 2 components. So that's why I showed you guys that. And then I wanted to show you guys some gears to get you familiar with doing a motion study with something with gears so you're not too, um, like scared by it. Um, let's see, for this one, the bearing and the bearing carrier are provided to you, but you guys do have to create all the gears here. I would suggest making them with toolbox, like I showed you guys in class. You don't have to make these from scratch. There's a toolbox, there's gears on there for you guys to create given the information that you have based on the number of teeth, I believe, should be given to you somewhere. Oh, based on this drawing, you're given the number of teeth for each gear. So the ring gear has 72 teeth, which is the red one. The sun gear has 36 teeth, which is the yellow one, and the planet gear has 18 teeth, um, which is the green one. And also note that you're given a diametral pitch of 24 for all gears. And I wanted to see, let's see, let's close this. I don't need this. Let's do a new part file. I just want to see if you make, a gear on SolidWorks through the toolbox. Um, what information do you need? So if we go to toolbox, let's find I forget, is it metric or standard? Doesn't really matter. These are, doesn't say, doesn't matter though. Let's do metric. Let's do a gear. Uh, do a spur gear. Let's do a spur gear. So we'll create. So let's say you need the number of teeth, and does it say the diametral pitch anywhere? Shaft diameter, hub, face width, pressure angle, number of teeth. So it doesn't look like it asks for the diametral pitch anywhere. But you might need to know this at some point. So I just looked up the formula um for the pitch diameter, because there is a relationship between the diametral pitch and the number of teeth. Let's say at some point you're not given the number of teeth. Let's say you're only given the pitch diameter and the diametral pitch. With those two, you should be able to solve for the number of teeth, right? So if D is equal to N over P, then to solve for N, you would multiply P to both sides. So diametral pitch, is that right? N over P. Yeah, diametral pitch times the pitch diameter is equal to the number of teeth. Um, but in this case, you're given, where are we? You're given the diametral pitch and the number of teeth, so it works out. Just FYI, keep that formula in mind so you can solve for the number of teeth if you ever have to. But that's all I have for you guys. Just want to give you guys a short introduction on the SolidWorks motion. So hopefully that helps you guys with assignment 13. If you have any questions, feel free to reach out. Thank you.